haloarenes, which shows that electrophile can easily comes and attacks, especially at the ortho as well as at the para, not at the meta. So the chloroform, we all know that it is a sweet smelling liquid with a boiling point of 334 Kelvin and it is a non-inflammable. So here the halogenation means the process of adding the halogen atom. Friedelcraft reactions are of two types. The Friedelcraft Oscillation and another one is Friedelcraft Alkylation. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, we are dealing with the unit called Haloalkanes and Haloarenes. Under this unit, we have discussed about the elimination reactions and greatly we have studied about the reactions with the metal. How does the haloarenes, which will be reacts with the metal, and also we have discussed about the some of the important reactions of haloarenes. Today, let us move on to the last topic of this unit by understanding electrophilic substitution reaction and reactions with the metal and PolyHalogen compound. We'll see how does electrophilic substitution reactions will also taking place in the haloarenes. Okay. So the halo group is an electron withdrawing group, as we all know that, and it get its ortho and para directing electrophile substitution reaction due to the resonance. So already we have understood that by looking at the resonance structure of the haloarenes, especially at the ortho group, at the para group, it gets a negative charge. Wherever it gets the negative charge, our electrophile can easily attract it towards a negatively charged center, thereby it forms a electrophilic substitution reaction. So we'll see that by taking up with the one example. Okay, so here I have a haloarenes where this is my aromatic benzene ring with one halogen atom. So here you can imagine with a chlorine also where it consists of 3 lone pairs of electron. Any one pair which has been moved towards this bond, thereby it forms a double bond with the carbon and halogen. One of the bond will be get shifted. You can see that as a result of this you will get this resonance structure. At the ortho position you can see that there is a negatively charged center. So that our electrophile can easily come attacks on the center, thereby it forms what? Ortho substituted product. Okay, again this is an unstable, it will be, this charge will be moved back so that the double bond will be moved towards this, thereby it shows that at the para position also the electrophile can easily get attacked towards it, thereby it forms a electrophilic substitution reactions. Again this charges which is unstable, it will be moved towards this, thereby double bond which is also get moved up, and shows that especially at the ortho side. Okay, so we know that this is a ortho side and this is a meta and this is a para, right? So our haloarenes, which shows that electrophile can easily comes and attacks, especially at the ortho as well as at the para, not at the meta. This is a one thing that it shows that the electrophilic substitution reactions will be also taking place in a haloarenes where the electrophile will be goes and attacks, especially at the ortho as well as at the para position, thereby it forms a ortho substituted product and para substituted product. Okay, so due to the negative inductive effect of halo group, rings will be get little deactivated. As a result of this, electrophilic substitution in the haloarenes, which are very slow, and also it requires a more drastic condition. So why the electrophilic substitution reactions are very slow and it requires a drastic condition? Because of the negative inductive effect. Because of what? Negative inductive effects, you know. In case of haloarenes, if you want to get this ortho substituted and para substituted product, you need a drastic condition and the reactions which is also very slow. We'll see with some of the example so that you will understand that how does the ortho and para substituted product will be formed by an electrophilic attack. Okay, first I'll go with the halogenation. So here the halogenation means the process of adding the halogen atom. Okay. So when the chlorobenzene is heated with an chlorine in presence of anhydrous aluminium chloride, the mixture of ortho and the para substituted dichlorobenzene will be formed. Again, you have taken an haloarenes it is, and name of this compound is chlorobenzene, right? It is chlorobenzene, which has been treated with what? Halogen in presence of anhydrous ferric chloride, or you can take anhydrous aluminium chloride also. So what will happen? This chlorine will goes and substituted at the ortho and the para position, thereby it forms a dichlorobenzene. It forms what? Dichlorobenzene. You can see that the name of this product is, where the chlorine group will be get attached to the first and the fourth carbon atom. So it is 1,4 dichlorobenzene. Similarly, you can see that it is 1,2 dichlorobenzene. Where the electrophile can easily get attacked, the electrophile can easily get attracted towards the ortho and the para position. Thereby, it forms a dichlorobenzene. And this process of adding an halogen atom, hence it is known as what? Halogenation. Next, we have nitration. Nitration in the sense we are adding what? Nitro group to the benzene ring. Hence, it is known as what? Nitration. Okay. When chlorobenzene, which has been heated with the mixture of concentrated nitric acid and concentrated sulfuric acid, a mixture of ortho and a para, chloronitrobenzene will be formed. So, the mixture of HNO3 and H2SO4, which is known as what? Nitrating mixture. Okay. You can see that this is a concentrated H2SO4 and concentrated HNO3. So, what does it happen if you take the chlorobenzene? So, what will happen? This nitro group will be goes and substituted at ortho and at the para position. Thereby, it forms a 1-chloro-2-nitrobenzene. Again, you can see that where the carbon and chlorine bonds will be formed. You can see that. So, it is 1 and 2nd. To the first carbon atom, the chlorine group will be attached. To the second carbon atom, nitro group will be attached. So, it is 1-chloro-2-nitrobenzene. And the name of this compound is 1-chloro-4-nitrobenzene, which is nothing but a chloronitrobenzene, where the nitro group, again it is an electrophile which got attacked at the ortho position as well as at the para position. Thereby, it undergo electrophilic substitution reaction. Next, we have sulfonation. So, what is sulfonation? We'll see now. When chlorobenzene, which has been heated with concentrated H2SO4, a mixture of ortho and a para, chlorobenzene sulfonic acid will be formed. So, here we are taking the chlorobenzene, which is nothing but a haloarenes, which has been treated with concentrated H2SO4. Upon heating, again this sulfonic group, that is SO3H group, will be goes and occupies at ortho as well as at the para position. Thereby, it forms a chlorosulfonic acid. The name of the compound is again 2-chlorobenzene, or you can say that 2-chlorosulfonic acid. Thereby, you can consider this is the first carbon atom and this is the second. So, it is 2-chlorobenzene sulfonic acid. So, it is 4-chloro, 1, 2, 3, 4. Okay. So, it is 4-chlorobenzene sulfonic acid. So, where the sulfonic group will be get attached to the ortho and to the para position. Next, we have Friedelcraft reaction. So, here also the Friedelcraft reactions are of two types. The Friedelcraft acylation and another one is Friedelcraft alkylation. We'll see with the alkylation first. So, the Friedelcraft alkylation means the process of adding one alkyl group to the benzene ring. Okay. So, when chlorobenzene, which has been heated with methyl chloride in presence of anhydrous aluminium chloride as a catalyst, the mixture of ortho and a para, chlorotoluene will be formed. So, this is my chlorobenzene, which has been heated with methyl chloride in presence of anhydrous aluminium chloride. So, what will happen? This methyl group that goes and substituted at ortho as well as at the para position, thereby it forms a ortho and a para chlorotoluene. Okay. So, again the name of this compound is 1-chloro 2-methyl benzene, and you can see that it is 1-chloro 4-methyl benzene. You can see that you are introducing what? Methyl group to the benzene ring. Hence, it is a Friedelcraft alkylation, where the alkyl group which has been introduced to the benzene ring. Next is acylation. The process of adding the acyl group to the benzene ring is known as what? Acylation. Okay. So, what is that acyl group? This CH3COO. CH3COO is a acyl group. Okay. When chlorobenzene, which has been heated with acyl chloride in presence of anhydrous aluminum chloride as a catalyst, the mixture of ortho and a para substituted product will be formed, and that is known as what? Chloroacetophenol. So, I am taking what? Chlorobenzene, which has been treated with what? Acyl chloride. In presence of anhydrous aluminum chloride, this acyl group will be goes and substituted to the ortho and at a para position. Thereby, it forms a 2-chloroacetophenol and 4-chloroacetophenol. Okay, you can see that if you write the benzene ring with C double bond O CH3. This is known as what? Acetophenol. This is a acetophenol. If the chlorine is there, we say it is chloroacetophenol. Okay. Next, we have the reactions with the metal. Let's see how does this haloarenes can also react with a metal. The first reaction is Woods fitting reaction, and for the examination point of view, it is very important and it can be asked for 2 to 3 marks. Okay. When the mixture of alkyl halides and aryl halide, which has been heated with sodium metal in presence of dry ether, you will get a alkyl arene, or you can say that you will get a alkyl substituted benzene ring. So, you can see that we have taken what? Haloarenes, and we have taken haloalkanes, which has been treated with the sodium metal. In presence of dry ether, the sodium will take up this halogen to form a sodium halide, and also this R will be get substituted, thereby it forms a alkyl arene, where the alkyl group will be get substituted to the benzene ring and forms a alkyl arene. We'll take up one example. So here, this is a bromobenzene which has been treated with a bromomethane. So again, our sodium will carry this bromine to form a NABR. In presence of dry ether, this CH3 group will goes and occupies to the ortho position, thereby it forms a toluene. Okay, this is known as what? Woods fitting reaction. Next, we have fitting reaction. Again, this can be asked for 2 marks. Okay, when aryl halides, which has been heated with sodium metal in presence of dry ether to form what? Diphenyl. So here I have considered the aryl halides, which has been treated with the sodium metal in presence of dry ether. What will happen? The sodium will take up the halogen to form a sodium halide, and biphenyl will be formed. Instead of writing this reaction, you can rewrite this reaction also like this. Okay. So our sodium will take up this halogen in presence of dry ether. Okay, it forms what? NaX, 2NaX. Thereby, it forms an biphenyl. So in the examination, it is a biphenyl group. So in the examination, if you forgot to write the bond between the two benzene ring, again it's a waste of writing the reaction. So you need to show the bond between the two benzene ring, thereby you are showing what? Fitting reaction. Okay. Next we have polyhalogen compounds. So till now we have studied about the haloalkanes and haloarenes. We need to understand if more number of halogen atoms which has been attached to the carbon chain, we say it is polyhalogen compounds. We'll discuss with few of the polyhalogen compounds and their uses as well as their environmental impact. The first one is dichloromethane and the formula will be CH2Cl2. You can see that there are two chlorine group will be attached to the carbon chain, right? So the structure will be like this. So it is CH2Cl2. So in the carbon, where the 4 valency which has been substituted by 2 of the chlorine group and 2 by the hydrogen atom, thereby it forms a dichloromethane. What are the uses? It is used as a solvent for the drug industry and it is used as a paint remover and a propellant for the aerosols and in the cleaning agents of the metals as well as for the alkyl benzene will be formed. Coming into the environmental impact of this dichlorobenzene, it is direct contact to our skin develops a redness as well as with a burning sensation to our skin and it is very harmful to our central nervous system and the high level in the air can also cause us a nausea, numbness, especially on the fingers as well as at the toes. If it is present in a higher quantity in the air, it causes a numbness. Coming into the next compound, that is trichloromethane, where you can see that if one of in the carbon, all the 3 valency will be get substituted by a chlorine group and remaining 1 hydrogen it is there, then we say it is trichloromethane. Similarly, we say with another name known as chloroform. Okay, so the chloroform, we all know that it is a sweet swelling liquid with a boiling point of 334 Kelvin and it is a non-inflammable, but the vapor can also cause a unconsciousness. Okay, when it is exposed to light in presence of air, it will be decomposed to give what? Phosgene. This phosgene, it is a very poisonous gas and therefore it always stored in a dark bottle. Why do they stored in a dark bottle? If you kept outside, it can react with atmospheric oxygen, thereby it forms a phosgene and phosgene is a very dangerous gas and it is a poisonous gas too. That is why it is stored in the dark bottles. Okay, and coming into their uses, it is used as a solvent for the fats, oil as well as with the varnishes, wax, resin as well as for the rubber and for the preparations of chlorotone, that is as a drug, and a chloropicrin. In that preparation we use what? Chloroform, and specially it is used as a anesthetic after being mixed with an ether and in the manufacturing of freons, especially with the refrigerator we will use a chloroform. Coming into their environmental impact, on inhalation it depresses the central nervous system and causes a headache as well as with a dizziness, and chronic exposure damages the liver as well as with the kidney, and exposures to sunlight with the air, it slowly decomposes to give what? Phosgene gas. It is a dangerous gas. The ethanol which has been added to retard the oxidation of phosgene into the harmless gas, thereby it avoids to form a harmless ethyl carbonate. So 1% of ethanol will be added to not to form a phosgene. Instead of that, it forms what? Ethyl carbonate. Again, it is not so harmful. Coming in the next polyhalogen compound. So here again we are preparing the carbon by replacing all 3 hydrogen with an iodide, which is known as what? Triiodomethane. Okay, or it is known as what? Iodoform. It is a yellow crystal solid with a pungent characteristics odor with a melting point of 392 Kelvin and it is stream violet and it is used as antiseptic agent for dressing of wounds. So hope you know that when you visit to the hospital, they'll clean the wounds by using this iodoform or with a trichloromethane, which is a dark brown color solution they'll use. So it is one of the antiseptic agent. Okay. So it is antiseptic for the dressing of wounds, and in the manufacturing of some of the pharmaceuticals, we use this iodoform. And coming into the environmental impact, when it has come in contact with our skin, the iodine which liberated and which is responsible for many causes, or it will be responsible for releasing the iodine gas. It's not so good to inhale the iodine gas, that is why it's too poisonous, and it is used as for the antiseptic properties and for the objectionable smell. As I have told you that it has an objectionable smell, so most of the people, they don't like the smell of the iodine which is there in the iodoform, so which is poisonous too. Next we have tetrachloromethane, where all the hydrogen which has been replaced, and it has been replaced with a chlorine to form a tetrachloromethane, or it is CCl4, or you can say carbon tetrachloride also. It is a liquid with a boiling point of 350. It is a non-inflammable, hence it is used as a solvent for the fats, oil and waxes and resins also. It is used in fire extinguisher under the name known as pyrene. Coming into the uses, extensively it is used in a fire extinguisher, and it is used for preparations of many reactants, hence it is used as a solvent, and also it is used in a dry cleaning purposes, and in the medicines as a helminthicides for the eliminations of hookworms. So earlierly the farmers used to use this chloroform, but nowadays it has been banned. Okay. Coming into the environmental impact, the vapors which we have breathed in, which causes a nausea, dizziness, vomiting, and may also causes a damage to the nerve cells. Thereby, it avoid the signals which has been passed to in our nerve cells. Okay. On exposures, it can also causes a cancer, irregular heat breath, and also the person may go to the coma. It is very, very important. If you are continuously, if you are exposed to the carbon tetrachloride, the person may goes to the coma also. And the vapor depletes the ozone layer, as we all know that the carbon tetrachloride vapors, which mainly causes a ozone depletion, right? So the ozone hole which permits the ultraviolet light which is directly enters to the sunlight, so that if the ozone light which is get depleted because of this CCl4, so the sun radiation can directly enters to the earth, which also causes what? A global warming. Okay, and it also causes the skin cancer. Thereby, it affects to our immune system also, and causes many diseases as well as with a disorder. Next is freon, which is also known as what? CFCs. Okay, the freons are the small organic compounds which are containing carbon, chlorine as well as with a fluorine, and most common freons are CF2Cl and CF3Cl, where the freon which is known as what? Freon 12 and freon 11. Coming into their uses, in the air conditioning and in the domestic refrigerator for the cooling purposes. Since we are using as a cooling purposes in the refrigerators as well as in the dry conditioners, the CFC gas which mainly causes a global warming, right, as well as with the carbon tetrachloride. So this is a major cause for that, and as a propellant in the aerosol and forms a spray out of the decorums and in the cleaners as well as in the insecticide and haloethane, which will be used as the inhalation of anesthetics. Coming into the environmental problem or impact, most of the freons are eventually makes the way to the atmosphere, where it diffuses the unchanged into the stratosphere. In stratosphere, the freons are able to initiate the radical chain reaction, then it can upset the natural ozone layer which is surrounding to the earth. That is what I have already told you, that the CFC is not only be used as a coolant in the air conditioner as well as in the refrigerator, it mainly affects to our ozone layer, thereby it causes what? Global warming. Lastly, we have the dichloro-diphenyl trichloroethane, that is nothing but a DDT. Hope you all know that. It is mainly used as what? Insecticide to avoid the flies as well as mosquito as well as with the crop pets, and as a anti-malarial. Okay, coming into their environmental impact, the DDT is the most chlorinated organic insecticide, and its a stability and the fact which soluble with a great problem. What does it mean? So we all know that it is an insecticide, DDT. If you apply to the plants, suppose if the rain comes, this DDT can easily wash away and that water can easily reach to the oceans. In the oceans, once the DDT which has been reached, it can also reaches to the fishes. Once it reaches to the fishes, it will be there in the digestive system, which is not completely degradable. Once we eat those fishes by human beings, it can also retain in our body, thereby it causes many problems. That is why it is not easily degradable. Nowadays, in most of the country, they have avoided the preparations or the manufacturing of this DDT because it's not good for their health. It will be completely recycled in every cycles of our life. That is why it is not completely degrading. It is banned in most of the country. Okay, so why it is known as ethane? You can see that the ethane structure is CH3 CH, right? CH3 CH3. You can see that if this carbon which consists of 3 hydrogen, all the 3 hydrogen atom, if it is replaced with a chlorine, and you can see that one of the hydrogen which has been replaced by putting the chlorobenzene, and other hydrogen which has been replaced by putting the chlorobenzene, hence the name which is known as what? Dichloro-diphenyl trichloroethane. It is the ethane only where you are going to replace the all hydrogen except one hydrogen with a chlorine as well as with a dichlorobenzene. So this is a use as well as with the environmental impact of the polyhalogen compounds. So this is all about the haloalkanes and haloarenes. So in this session, it is very important to understand what is the Woods fatigue and fatigue reaction and how does the electrophilic substitution reaction which also happens in the haloarenes. I'll come back with the next unit. Till that, take care, be safe. Thank you.